then sine 3x plus. Now this one is the one that you need to be careful with, because what do you see here? This is chain rule. It's going to be the chain rule. This is composition, right? Do you see an outer layer and inner layer there? Right? Outer is sine, inner is what? 3x. Would you like to continue with this one? Derivative of this? You're taking, first start with the outer layer. What's the derivative of sine of something?
Cosine.
Cosine. So you put cosine of what, 3x, good. And you're not done though, right? You're not done with this derivative. You still need to multiply this by what?
3.
The derivative of that, the derivative of 3x, which is your 3. See, that's your chain rule. And then we're not quite done, because what do we still have out here? X cubed. Yes? The cosine 3x times. Oh, okay, you're saying, does this need to be in parentheses? Not technically, because this is multiplication, right? So there's no pluses or minuses in here that would require that to distribute. I'm going to write this. I'm going to write one more line on this, so you can see like most likely how this would appear in the back of a book. It'd be like 3x squared sine 3x, and then what a book would do is take all this together, and they would just drop it out in front of that cosine. So they'd probably put like plus 3x cubed cosine 3x, just like that. Who has a question? Yes?
I kind of think I know why, but I just want to confirm. The reason we got 3 from the cosine 3x was because we did x to the first power times 3, and then we subtracted 1 from the exponent.
Oh, you mean like y is the derivative of this 3?
Yeah.
You can look at it a couple of different ways. Here's one way is the way you're suggesting. If you have 3x and you want to take its derivative, right? You could look at that as being taking the derivative of 3x to the first power, right? That's the first power. So what you do is you bring the 1 out, right? If I bring the 1 out, 1 hits the 3, becomes 3, and then I have x to what power? 0, but anything to the 0 is 1. So you get 3 times 1, which is 3. That's one way. The other way, which I think is much better than that, not to say that's bad, I mean but it's just to remember that when you have a constant times a function, and you take the derivative, just ignore the constant, and just take derivative of that. And just, we know that the derivative of that is 1. So you just get 3 times 1. But it works both ways. I just think on a test, this just eats up another 30 seconds that you want, at the end or something. Yes? On this exam, on your next exam, no. I want to see you execute the calculus, which is actually the chain rule happening. The rest is algebra, right? So I really am focused on, are you getting the calculus part of this? So you can see in a problem like this that I've mixed up, I'm starting to mix things up, right? Like the previous problem, we had a chain rule, but inside the inner function was a product. Here I gave you a product, and then one part of them required chain, right? Can you see how this could start to get pretty complicated? Like if you start mixing too many things together. But as long as you understand the mechanics of the rules, then you just take it slow and work it out, all right? Let's try another one. I've been teaching calculus for 20 years now. It's been 20 years, I can't believe that. More than 20 actually, probably I think 2000 was the first year I stood in front of a calculus class. So many of you were not even alive at that point, but and every time I get to chain rule, it seems like I try something a little different because I have yet to find a way to teach this in a way that everybody gets it. I've never been in a class where everybody, we walk out and everyone understands chain rule. So I'm just trying something, I mean, it's similar to what I always do, but I'm trying something. I haven't shown you the rule yet, right? Just trying to get you to understand the concept first. So, what do y'all see? Do you see a function inside of another function? Depends on how you look at this, right? Let me help. Is this not the same thing? Isn't that what this notation means? Sine cubed x really means you take the sine function and cube it, right? Y'all agree with that? Why are y'all looking at me like that?
Unsure.
You're unsure?
Yeah.
Okay, well then I'm telling you that's what it means then. Okay, this means this. I mean, in pre-cal we did like sine squared, right? Sine squared x, cosine squared x. What we really, it was just a shorthand. That's all it was, right? When we were in pre-cal and we write sine squared x, what we really meant was take the sine function and square it. That's what that notation represents. Now there's you have to be a little bit careful because in pre-cal, if we write this, this does not mean sine x to the -1. That's not what we mean in pre-cal. This is the inverse trig function, which is a different type of function. So this is one of those places in math where our notation just kind of sucks, and we should have had better notation. So sometimes we use, instead of this, we write arc sine, so that there's no -1 to confuse us. But if it's a number other than -1, then this is what it means. So if you replace that with an n, replace that with an n, that's what that notation represents. So if you now believe this is true, do you see a function inside of another function? Think of it this way. If I told you to plug in an x here, who gets the x first? You're going to do sine, right? So if I say, hey, plug in 2 for x, plug in 2, you would take 2, and then you'd get on your calculator and do sine of 2, right? And then what would you do after that? You cube it. So that's two different functions, right? That's two different things that just happened. You took sine of x and you plugged it into the cubed, right? That's composition of two functions. Look at it like it's like a chain of events happening, right? X first goes into the sine function, comes out as sine x. Then that goes into the cubed function and comes out as sine x cubed, right? That's kind of what's happening there. You have a chain of events. Sine gets it first, then the cubed gets it. Yeah? No? Okay, so any volunteers for the derivative? How about what's the outer function? What's the outer one? The cubed, right? What's the inner function? The sine. So we always start with the outer, right? So I'm going to get my little dirty, nasty rag that hasn't been washed since the beginning of the semester, right? I'm going to put it right here. That's the inner function. I'm going to cover it up. What is the derivative, right? What is the derivative of a dirty rag cubed? 3 dirty rags squared. Yes? 3 dirty rags squared. 3 dirty rags squared. So my dirty rag is sine x, right? That goes here. Are we done? No. What do we need next? We've taken care of this, right? We've taken care of the cubed. Now you need to go take care of the inner function, and we're going to multiply. So what goes here? Cosine x. We're done. I'll give you one just like it below, just so you can see if you can figure this out. Bless you. Do you see an inner function, outer function? What's the inner? Sine? Because that's the function that would get x first, right? That's the inner function. And then after you do that, the outer function would be the square root. So whenever we differentiate using the chain rule, we always start with the outer function first. So I don't want to use my dirty rag again. Let's use my glasses. I'm going to cover up the inner function there. Okay? F prime x equals. Who wants this? Somebody new. You already went. You already went. You already went. No? Did you go?
Oh, yeah. I would.
You went. You went. Oh, do you have a question?
No, I haven't gone.
Oh, you have? I thought you did. Oh, you asked a question. Sorry. Go ahead.
I think if we're looking at just the root, then it would be something to go on half pound.
It would be, yes. But do you remember I told you also with square roots, try and memorize the derivative of a square root?
1/2.
Okay, so 1 over. So what you're doing is you're saying, hey, I've got the square root of some really cool glasses, right? And I want the derivative of that, which would be 1 over 2 square root of,
X?
well, but it's not x, it's my cool glasses.
The cool glasses?
Yeah, so it's my cool glasses that go here, right? So it's sine x here. Understand?
Yeah.
Everybody understand? Times, we're not done. Now we've done the outer, right? So now go to the inner function, which were my cool glasses, and you can go differentiate that now. So, which is what? Cosine x, and that goes right here. Okay, you ready for the rule? I'm going to write the rule down, and then we're going to do more examples. I'm putting the rule on here just so you have something to look at, and it's also on your formula sheets. The chain rule says this. That if you have a function, and then inside of that function, you have another function. So that's composition. Back in college algebra, that's the way we wrote f of g of x. If you want to take the derivative of this, all right, then what it's going to be, let's see if we can't come up with the formula on our own right now. What's the inner function here? F or g? G. What's the outer function? F, right? So when we differentiate using chain rule, we always start with the outer, right? Because remember, you did like the square root before you did the sine. So you always start with the outer, and you take its derivative, right? And inside of it, you put the inner function, but you don't touch it. So what would that be for us? F is the outer, right? So I'd write F. I want its derivative, but inside of it, what do I plug in? G of x, okay? And then after you're done with that, you're going to multiply by what? The derivative of that inner thing, which would be g prime of x. And that's the chain rule. Does that chain rule make sense in terms of, does it match what we've been doing? Yes? It's the derivative of the outer one. I'm going to write this in words. I don't normally do that. Maybe this will help. This right here is the derivative of the outer function evaluated at the inner function. So I'm taking the derivative of the outer function, but I'm evaluating it. I'm plugging into it the inner function. This is the derivative of the inner function. And of course, don't forget they're multiplied. Okay, the formula says you multiply. All right, I'm going to put 3 problems on the board. I want you to work them. After that, we're going to move on to some harder problems, all right? This is us just trying to see if we can get this rocket off the launch pad or not. First one, try these derivatives. F of x equals, I'm going to see what the book has here. Is some of their first problems here. Okay. Yeah. I'm not using these exactly. I'm just kind of making up my own based on what I'm seeing here. They kind of jump right in here. All right, see how you do. Take some time here. Let's say we'll take about 8 minutes. See how much you can do. You can talk to each other, help each other, whatever you want. I'm hoping everyone gets the first one. The second one might be a little bumpy. Third one really could cause some issues. And I'll be back. I'm gonna go get a drink. Excuse me, I'm just gonna grab this. Are you doing okay? Okay. How about over here? Y'all doing all right? Any questions? Three, and then don't touch the inside. Squared though, because you're using like the rule, right? Okay, and then times, that's the derivative of the inside, and that's it.
Okay. So
Yep.
And then the one just drops.
Just goes to a zero. Yep. Y'all doing all right? Yeah, feel like it? Want me to look at anything?
Yeah.
The first one? Don't forget to square it on that one. This one. Because you brought the 3 out, right? But you're using that power rule, right? That when you bring something out, it's still to the second power. So just put a little 2 on the top. Right there, yep. Understand? Okay, and then the rest of it's fine. And then on this one, you're using product rule. Excellent. Good. Okay, almost. There's a little problem with that secant x, tangent x, but just leave it for now. See if you can move on to the next one. That's gonna be something I'm gonna talk to everyone about. How are we doing here? First one's right. Second one, oh, there's an x in front of the secant 4x. I think you wrote the problem down wrong. No, you wrote it down wrong, so you're gonna have to redo that. And that one, So how did you get that top right corner there? You're doing quotient rule, right?
Yeah.
So the first thing you did was a derivative of the top times the bottom, and then minus the derivative of the bottom times the top. So the top is x, right? Not x plus 1?
Yeah, that's X.
Yeah, hold on, let me get my... It's just slightly off. So this right here, you're doing derivative of that times that. Is that where that came from?
Yeah.
Okay, and then minus the derivative of this, which is 1, times that.
Oh,
Then you have too much there. You see what I'm saying?
Yeah.
And then the bottom square. Everything else is right. And then go back and look at that one. How we doing? How you feeling?
For this one,
It's a little weird looking, isn't it?
yes. Do you do the quotient rule after you do the,
Yeah, after you take care of the root, separate from that, you do the quotient rule next to it.
so that zero?
Derivative of the top times the bottom. Yes, minus,
yeah.
and then over the thing squared. Okay, time-wise, I've got to keep going. Sorry, I couldn't get around to everybody. Let's take a look at these. All right, so on this first one, we have, a box of tissue. We have composition, right? We have something to a power of 3. So I want to take the derivative of a box of tissue cubed, which means you're going to just use the power rule, right? The 3 comes out, the box of tissue to the second power. Don't forget that second power. So for this, the derivative here would be, heads up, I'm gonna miss. No, I think I'm gonna make it. Just feels good. Oh, I was short by like an inch. That was close, right? Yeah. Okay, so the 3 comes out, and then it was x to the 5th plus x plus 1, then to the second power. All right. I'm not done though, right? Need to multiply that times the derivative of the box, right? So now I can do that. Derivative of that should be just, you can do them one at a time, right? Each one separately, because there's addition between those. So 5x to the 4th plus 1. We're done. Questions on that? Yes?
On the ending, I thought it was 2 because like I was thinking the derivative of x would be 1 and then 1 plus 1.
What's the derivative of a constant?
That was 0.
0. So you only keep the constant if it's attached to a function. If it's by itself, the derivative will always be 0. Okay, we're good there? Okay, the next one, you need to see that this was a product. And so you're going to do the product rule. So I'm going to do this. Derivative of the first one, I'm going to write the product rule out, times the second one, plus the derivative of the second one, times the first one. That's my product rule just written. Let me start working on these derivatives. Well, fortunately for me, the derivative of x is 1, so that's just secant 4x. Plus, now, here's the one that most people mess up. Okay, that's why I put it up here. That is composition, right? 4x is being plugged into the secant function. So I'm going to get my mouse. This is going to be the inner function. Careful, careful, careful. What is the derivative of secant of a mouse? Look at your formula sheet. So what's the derivative of secant x on your formulas? Secant x tangent x, right? But do we have secant x tangent x? We have secant mouse tangent mouse. Okay? So that's right there. I'm going to go, derivative of that is secant of that 4x, and then tangent of that 4x. The biggest mistake students do there is they write secant x tangent x. It's got to be secant 4x tangent 4x. So all I've done there is I've taken the derivative of the secant now, right? That's this part. And now what do I still need to tack on to the end of that? The derivative of the actual mouse, right? Which would be 4. Am I done? No, what am I missing? The actual x right here that finishes off the product rule. Look at that carefully, and if you have any questions on where I got any of it, now is a good time to ask. We're okay? Okay, I'm moving on then. This one, we have composition. Outer function is the root. The inner function, I'm going to look at as being all of this. And the reason I'm looking at it as all of this is because this right here, if I had to take the derivative, which I will have to, if I do, I'm okay with that because that's a quotient, and I know how to take derivative of quotients. So I should be able to handle this. So we start out, the derivative here will be, okay, so I don't know, I'm kind of, oh, my textbook. I'm trying to be equal opportunity up here. Everything on my table gets fair chance. I have to take derivative of the square root of my book, right? Derivative of the square root of my book is 1 over 2 square roots of my book. So 1 over 2 square roots of my book. Now I realize some of you rewrote this as all of this to the half power and then brought the half out and subtracted 1. That's correct as well. But like I said from the offset when we started talking about square root and the derivative, I always just use that formula. Are we done?
No.
No, we have to multiply, right, by the derivative of the book, right? The derivative of this, which is a quotient, so I have to apply the quotient rule. So I'm going to actually write the rule out. The rule says that I take derivative of the top times the bottom minus the derivative of the bottom times the top, right, all over the bottom square. So I'll write it out kind of like a formula. And I'm just going to throw this whole thing in parentheses because all of it needs to be multiplied times this. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. That's my quotient rule. Yes? Oh, right here? Back on this one? Okay, so this was composition, right? There's outer and inner. So when we did the outer function, the derivative of secant of something is secant of it, tangent of it, right? So you're done with the secant. Now you had to take derivative of 4x. That's the inner function, right? And derivative of 4x would be 4. Because for the same reason, just cover up the 4. What's the derivative of x? 1, right? And 1 times 4 would give you the 4. Yes? Those little things like the 4, those are the things that people like forget to do on tests. Just be real careful because Of course, I won't, if you missed the 4 here, if you got everything else right and you were missing the 4, it wouldn't be like 0 points. You would get partial credit, of course, but I can't possibly give you full credit if you're missing things like that. Where? This? That rule? Right? So I'm using the quotient rule on that piece right there. I have a top, I have a bottom, right? So I'm using the quotient rule. All right, I'm not done. I need to actually calculate this. So this is going to be 1 over 2 square roots of x over x plus 1 times, and then in here, derivative of x is 1. So I just have 1 times x plus 1 is x plus 1. Then minus derivative of this is what? 1 as well. And 1 times x is x. So I have minus x here. And then all over x plus 1, that quantity squared, right? And you could actually kill off those x's if you want to on the top. X minus x, you'll see that up top. So you would just be left with a 1 on top in that fraction. And that would be your next line. We just leave it like that.
So was the derivative of x plus 1 0?
1. It was 1. Right? Because what's derivative of x? 1 plus what's derivative of 1? 0, right? So that's 1. And then 1 times x gives you x. And I'm subtracting it. So there it is. Y'all see how this is building, right? When we started off this whole idea of derivatives, it was how do you deal with x to powers? Yes, got it. Then how do we do it when we have addition and subtraction? Okay, got it. How do we do products? Got it. Quotients, got it. Now the chain, and now everything is together, right? So you have to understand all these other concepts to be able to do the chain rule. Every little thing has to be kind of clear in your mind. All right. Ready for some more? Oops. I'm going to give you something I haven't given you yet. How about this? Haven't done this yet. So are there any multiplications here? Do you see any products? You shouldn't see any products. This is composition, but you've got multiple composition, right? This is actually 3 functions being composed together. If we think of it visually, first thing that happens is x goes in, right, and goes